All right, welcome to section 8.7, Systems of Inequalities. Now it says systems of inequalities. A few of the graphs, first we'll do just an inequality, and then we'll do a system of inequalities. And they do have a few differences in their how to proceed. So just gave you some examples of inequalities. Nothing to do for those. They were just saying these are inequalities. This is, by the way, a linear inequality. This would be a hyperbola, and this would be a parabola. And you can have an inequality on any of those things. But the big thing is you have a less than, a less than or equal to, a greater than, or a greater than or equal to in the inequality as opposed to an equal sign. So they ask you to graph this one, and let's go through the actual procedure. The author does an awful lot of extra work on this one because he hasn't really, he plotted all these points to determine whether it belongs to the solution set or not. But let's get to the actual process, and I'll go back. All right, so the process, step one, mentally, I suppose, replace the inequality symbol with an equal sign and graph that resulting equation. So it's called an equation if it has an equal sign. If it has an inequality, like a less than, it's called an inequality. So we replace it, we need to change it to an equation so we can graph it. Now, if it's a strict inequality, strict meaning less than and greater than, we draw it with dashes. And if it's a non-strict inequality, means meaning less than or equal to or greater than or equal to, we use a solid graph. And on the website, there's a way to make a graph dashed by clicking on a figure that looks something like this. Now the graph will always separate the plane into two or more regions. So keep in mind, we're not just talking about a line. We're talking about maybe a parabola. If your graph is a parabola, you've created two or more regions. Actually, any figure we're drawing, you could pretty much think of it as two regions. The only exception to that might be a hyperbola. If you have a hyperbola, are there three regions? Yeah. Inside, the left, the middle, or the right. So that's what the author's saying. There might be more than two. It might even be more than two regions, just from a single equation or inequality. But for the most part, it's two, and that's a big thing to know. All right. So the author says we want to test a point in each region to see whether it's true or false and shade the true regions. I'm going to say it's simpler than that. Test a point anywhere if there are only two regions. If that point is false, the other region is true. If the test point is true, the other region is false. So if there are two regions, there's no reason to test each region. But all right, let's look at this. So real quickly, I know that I can think of that as x squared plus y squared equals 3 squared, a circle of radius 3, and I'm using a solid line because, I shouldn't call it a line, but I'm using a solid, I'm not dashing my circle because it included equals. This has created two sides, an inside and an outside. My favorite point to test is 0, 0. So let's test that in the original inequality. 0 plus 0, well, 0 squared plus 0 squared is less than 9, results in 0 is less than 9. So I want to answer that question. That is true. So the test point gave me something true. Now, I am going to discourage putting a t next to your test point. Put the t next to the boundary of that test point, and an f on the other side of that boundary. And that will help us later. All right. So again, what did I want to do? I want to shade the true region and not shade the false region. So that would be how we could run that test. The author, looks like the author kind of overdid it by picking a point on the outside for 0 and substituting that in here. Well, we get 4 squared is less than, we get 16 is less than or equal to 9 for this test point, which is false. And so that just confirms the other side of the boundary is false. But like I said, certainly 2 sections, that's kind of not a good habit to get into. As soon as you get a test point that's either true or false, you know what happens for the rest of the equation. All right, so this is the author's image of what I did earlier. Let's see, let's look at this one here. All right, so this one is an actual system of linear inequalities, and they're linear because, the exponents are always 1 for all of the variables. And we should be able to graph something like this with our own, process. I'm looking at the way the author explained it. I'm not a fan of this, drawing 3. The thing is, we don't really have 3 grids when we're doing the work to create another grid. So, in practice, you're given one equation, and your job is to, make that work. So let me get my paper together, and we can still see it up there. I want to graph each of these lines. So let me graph this one. I'm going to call it the blue line. And I can tell that if x is 0, remember I'm thinking this is an equal sign right now. If x is 0, I get y equals 2. And if y is 0, I get x equals 1. So I want a solid line to go through those 2 points. And that's my line. Put it right there. Okay. Well, I didn't realize I was off the page a little bit. Okay, that's that line. But I'm not done with that line yet. Let's test 0, 0 in the original inequality. If I test 0, 0, I like that test point, and if it's not on the line, I use that test point. So again, for this first line, if I test 0, 0, I get 2 times 0 plus 0 is greater than or equal to 2, or 0 is greater than or equal to 2. That, of course, is false. So here's my test point. And what I said a moment ago is I don't want to label false at the test point itself. What I want to do is I want to label the side containing that test point is false, and that means the other side is true. So I'm done with that blue graph, and I'm so done with it, I'm actually going to change colors when I talk about the second equation. So the second equation is x minus 2y is less than or equal to 4. Do the same thing, graph it however you graph it. I like to just say x is 0, y would equal -2, and if y were 0, x would equal 4. Oh, it's not a, well, make it work, okay. There's my graph of that line. And once again, I need to test the points. So I need a test point, and I'll test that same point again, 0, 0. So this time I get 0 minus 0, or 0 is less than or equal to 4, which is true. 0 is less than 4. So the test point is on the true side, and that means the other side is the false side. So what I'm doing here is I'm using one graph, one test point, and I'm shading once. And the reason why I'm doing that is this whole procedure the author is trying to give us, maybe to help us understand this process, isn't the way the problem plays out on the computer. On the computer, you just have to draw each line. And then what? Well, then you're given this option to click this thing. It looks like a bottle of ink, I guess, with a drip coming out of it. You click that or drag it. I'm going to say click. You click it, and then you just want to click in the region where you see true in both boundaries. And it's only going to be one. So one region where it's true in both boundaries. This region here, created by the two lines, has a false and a true, so it's not true in both times. This one's false twice. All right. So you click here, and I got the wrong pen. The computer will do this for you if you just tap it, and it will hug those boundary lines that you created and shade that entire region. So you do have to draw the lines first before you can do the shading. In other words, if this red line weren't here and you clicked, from here to here, it would shade the entire boundary line, including an area we don't want shaded in the final answer. So make sure both of your lines are in place if they're lines, and then we'll click the area once. All right. So everything I just said, you would never actually create this or this. You draw the two lines and only shade once. So that's just the distinction I want to make. I don't disagree with what the author is doing here. The author is saying if you test 0, 0, you'll find out this is the true side. Yeah, I wrote false. You'll find out that's the true side. And if you test 0, 0, you'll find out this is the true side. So yeah, what the author is saying isn't inaccurate. It's just when it plays out, it feels a lot different than that. All right, I want to talk about a system of nonlinear equations. So we got to an example here. So on this one, notice the square. So since it's squared, we don't have a line. And this is a line. And let's see how this one plays out. in a real case. That paper, I don't think I want it at the bottom. I wanted it, oh man, try that again. Add my graph paper. Okay, so here's the problem, and I'm going to try to graph that solution here. And I'll need to write something down, bring something down here. All right, so I'll draw this one in black since that's the color I'm using right now. So do we know y equals minus x squared plus 4? Well, we certainly know y equals minus x squared is the parabola pointing down. Adding 4 would bring it up 1, 2, 3, 4. It would be a shift up 4. So 1, 2, 3, 4, and then the parabola pointing down. And I suppose it's nice to get some points that we know about. Yeah, I knew that was gonna. I should have known that was gonna happen. Okay. But we could add accuracy a little bit later. But with the graphing techniques on the computer, you would want to click on the vertex, which is 4, 0 or 0, 4. Yep. And this point right here works. It's 1, 3. I just know that because that's how parabolas work when they're upright. When you have the vertex, the next point over is, you have a vertex at 0, 0. The next point over is 1 over and 1 up. So I'm just going 1 over and 1 down because of the way the graph is drawn. But you could plot that point from the equation. But again, use the parabola graphing tool and tap that. I have the feeling that the computer doesn't have any graphs this complicated with the parabola. It might be more multiple choice. So the accuracy of this might not be required. All right. Now that I have the parabola drawn, I still need to test it. So back up here. If I test 0, 0, I'll get 0 is less than or equal to 4, which is true. So what I said before is I have my point. Don't label the point as true. Label the boundary as true. So this might not be helpful to me, but I'm going to put it, and we don't know exactly, we could put boundaries all over. I could put one here, I could put true there, I could put true down here, I could put true up here. I'm just saying I could do that. At the moment, I don't know if any of those, I don't know which one of those are going to be helpful, and I'll explain that in a moment. So I'm just going to do it once for now, and I'll add more of them later if I need to. All right, so that's that. I have that part drawn. So in blue, I'll draw the line, and the line is x minus y is greater than negative 2. If x is 0, y is 2, and if y is 0, x is negative 2. So negative 2, 0, that point. 0, 2 would be this point, solid line. Going through those 2 points. And the test point, 0, 0. 0 is greater or equal to negative 2. That is true. So here's my test point. And on the boundary, this is true. Now I'm going to put true here, and I'm going to put true here. And this is what I was talking about. You don't really know in advance which T is going to help you the most. If, for example, I was on the other side of this line, in other words, if, for example, this side were the true side, a T up here might be useful to see the pair, but I think I have enough to know where I want to shade. Where do I want to shade? Well, I want to shade where it's doubly true, so below the line and inside the parabola. So I just want to point out that if this problem had said, let's have a little fun with this. If this problem had said, just one change, if this had said x minus y is less than -2, how would that change the problem? Do you see it? Well, I'd still have these same points, but this would be a dashed line instead of a solid line. And when I tested 0, 0, I'd have 0 is less than -2, which is false. So the other side would be the true side. So I'd have dashed lines, and I'd have this little area in here shaded with that one change. So it's a change, or maybe it's two changes. I changed the symbol, the direction, from less than to greater than, and I got rid of the, well, from greater than or equal to strictly less than. So with those changes, I'd get this result here. I want to mention that for two reasons. One is, if you do see a multiple choice question, that might be the only difference. The only difference might be that they gave you the right answer to a slightly different question, just they shaded here instead of there, and that could throw you off. But the other reason is that's exactly what the author seemed to accidentally do in this problem. Not exactly sure what's going on here. When the author drew this, he drew the line correctly, but shaded in the wrong area. So this is an example of the author, from the author's web page, and I'm not sure what happened. Did the author solve the wrong problem, or did they type the problem wrong, or is the solution wrong? But from the question that was given, it really should be shaded here. That's the only thing that should be shaded. I'm saying this is actually incorrect to shade there, and shading inside is fine. All of this shading is fine, but that should be the only answer. So one of the subtleties of something like that. All right. So one thing I like to do on problems like this is I do like to talk about inside and outside and above and below. Just they're not well-defined ideas, but it's a kind of a helpful description. And the reason why I bring that up is there's a really nice description whenever you have inequalities like these. We have inequalities, now this time both of them are greater than, you don't always get that, but when they say x is greater than 0, y is greater than 0, they mean quadrant 1. So this thing right here means in quadrant 1. That's pretty nice, because you can spend your time working on this. You still need to draw the lines, by the way. You need to drag a line. This line, the x-axis, is the line y equals 0, and this is the line x equals 0. In other words, you have to draw them so the ink thing works. But we know mentally that whatever inequality we get, we want the part that's in quadrant 1. So let me just show that didn't work. Okay. Show the solution. Okay. It's off the page, but I can show the solution by there. All right, so the author did the thing the author does with all the extra images, but you can see the solution right here. So you do you do have to draw all 4 of these lines, and you have to click in the right area. But what I'm saying is, if you have this line drawn, and this is the true side, and you have this line drawn, and this is the true side, through whatever process we're doing, you don't want to shade in any quadrant other than quadrant 1. You also need to draw the the line x equals 0, which is right on top of the y-axis, and the line y equals 0, and then click on it. So you need, if you have an equation with a system with 4 equations, yeah, you're going to need to draw all 4 of them because we're doing it on the computer, but your image will come to you more quickly just with the equation. So real quickly, I think I've already said more than I need on this, but I'm not trying to draw these accurately. I'm just saying, I'm just duplicating what I have here. If I have a line here and another line coming this way, to most of us, we have all the lines. This is even y equals 0, and this is even x equals 0, but it was already there as the asymptote, right? So if I try to shade right now, it won't work. You actually have to draw this line in with the graphing utility, and you have to draw this line in. Even though the asymptotes are there, they're not boundaries until you draw them in. All right. So all of these lines are drawn by you, and the x and y axis are already there by the computer, but you had to draw them. Now what? Well, through your testing procedure, you find out that this is the true region. Don't tap somewhere that's not in quadrant 1, meaning here or here. Yeah, you want to make sure it looks right, and it should just shade. And I don't even have it right after all that. Okay. And let's switch to the, all right. So we have the region shaded in purple. Not in, well, we have the author's purple region, but we have it shaded in the books, the website's very bright yellow. All right. Well, I think I said enough about this, hopefully. So that's the last section we cover in this chapter. There are a lot of things, of course, touched on in this chapter, chapter 8, but systems of inequalities is, or 8.7 is the last one. So make sure you see the name of the homeworks to indicate which sections we do and do not cover for that chapter. All right.